Hello class. Today we're going to deal with two specific triangles, equilateral, which means all sides are the same length, which would also mean all three angles are the same, equilateral and equiangular. And the other is isosceles, which has two what we call base angles that are always congruent, same measure, and the two sides that go with those base angles are always the same length. But before we begin, one of the most important ideas about figuring out the angles of a triangle is that any triangle is always a total of 180 degrees. No matter what size or shape triangle, it's always 180. So for instance, in example 1, we've got 74 degree angle, a 59 degree angle. We can call this one X. We absolutely know that that angle X plus 74 plus 59 is going to equal 180 degrees. And solving for X, you simply add these two together, you get X plus 133 equals 180. And subtract 133 from both sides, you get that X is 47 degrees. Now the same thing applies here. We know that in number 2 that these three angles must add up to be 180. So if we're solving for X, we take that top angle, X plus 88, add to it this bottom left angle, X plus 66, add to it this known angle, 46 degrees, and together all three have to add up to be 180 degrees. So combining like terms, we get 2x plus 200 equals 180 degrees. Subtracting 200 from both sides, we get negative 20. Divide both sides by 2, x is negative 10. Now some of you may be thinking, yeah, but you can't have a negative angle. That's true, but this is just the value for x. So for instance, if you plug negative 10 in here, that would mean that this is a 56 degree angle. So you got to be careful whether you're solving for x or solving for the angle, but in this case, we're simply solving for x, and that's problems 1 and 2. Alrighty, problems 3 and 4, class. Now, you'll discover that many of these geometric configurations, you have to start somewhere. We're trying to find this angle right here, but we don't have what that angle is. If we knew that angle, we would know that this angle plus 20 from 180 would equal that angle. So you got to start where you know what you're dealing with, and that's right here. We know these two angles, so let's call that one X. We know that 65 plus 75 plus that angle X equals 180. So if we add 65 and 75 from 180, we get that X is equal to 40 degrees. All right, so if that's 40 degrees, how do we know what this angle is? Well, the fact that this forms a right angle gives us the clue, because if this part of the right angle is 40, that part's got to be 50. Aha! So now we can find out this angle right here. It's 50 plus 20 is 70. From 180 would be 110 degrees. Now over here to number 4. Again, we're trying to find that angle we'll call X. Don't assume that it's a right angle, even though it kind of looks like it. We don't have the little right angle marker. So if I knew this angle, then this plus that would be 180, but I don't know that angle. I do know that this is 52. Now, if I knew this angle, I'll call that y. Y plus 52 plus this angle, those form 180 degrees because they form a straight line. So let's keep that in mind. All right, so I can get what I'm calling angle y by adding these two up and subtracting it from 180. And so when I do that, I got that that's 58 degrees. Again, if you missed that, I added these two together, subtracted it from 180, and that had to give me this one. Well, if I've got 58 here and 52 here, let's call that one Z. Well, 58 plus 52 plus angle Z has got to equal 180 degrees, because the three of these little angles, they all form a straight line in their base. So adding those up, I get that angle Z turns out to be 70 degrees. Okay, now I'm good to go. If I know that that's 70 and that's 23, 70 and 23, that's 93 from 180, then that means that this one has to be 87 degrees. Now you just want to take these things step by step by step. It's like putting together a puzzle. You just have to find the place to start, and everything then falls into place. So that's examples 3 and 4. All right, now we're ready for examples 5 through 8. Now, because we have two base angles that are indicated that are congruent, that's what these little curved, we call them tick marks. That means this angle is the same as that angle, which is different from this angle, so we know that this is an isosceles triangle. So if that angle is congruent with that angle, that means this side has to be congruent with that side. And we use these little tick marks to indicate that the sides are congruent. So if that is 8, that also has to be 8. Similarly, in number 6, because of these two base angles are congruent, we know this is isosceles, therefore this side and that side are the same length. They're congruent. So if this side is 8, we know this side has to be 8. So we set 2x minus 10 equal to 8. Add 10 to both sides. Get 18, divide by 2, so x would equal to 9. Okay, over to number 7. Now, once again, I don't have the base angles tick marked, but I do have two sides that are tick marked. So that means these two sides are congruent. Therefore, this is a isosceles triangle. Well, that means that that angle and that angle are congruent. So if this guy is 54, so is that one, 54 degrees. Now, number 6 tricks students, but it's really not, once you see what kind of triangle it is, then maybe the lights will go on. All right, we got 3 tick mark sides, indicating all 3 sides are congruent. Okay, equilateral triangle, which is also equiangular. And in any equilateral triangle, all 3 angles have to be 60 degrees, because you take 180, divide it by 3 equal parts. 180 divided by 3 is 60. So no matter if it's a huge equilateral or a little baby one, each angle is going to be 60 degrees. So that means that angle 2 is 60 degrees. Well, we know that 60 degrees then must equal the 7x plus 4. Subtracting 4 and then dividing by 7, x would equal to 8. So that's 5, 6, 7, and 8. Alrighty, for 9 and 10. Well, again, it's like putting together a puzzle. You just have to find the place to start. We're trying to find this angle right here. We know that this is isosceles because of 2 tick mark sides. So we know that that base angle and that base angle are congruent. The other angle, just for your information, we call the vertex angle. And that's what we're trying to find. All right, well, where do we start? Well, you got to start typically where you got some amount of information. All right, let's look up here. This 2 is isosceles because of these 2 tick marks. Notice that this is a single tick mark. That's a double tick mark. That's to tell the reader that this length is different from that one, but this one and that one are the same. All right, so this is a base angle, which means the other base angle also has to be 75. All right, 75 plus 75, that's going to be 150, which means that this angle here is going to be 180 minus 150, or 30 degrees. Okay, well, does that help us? Sure, because what's the relationship between this angle and this one here? Notice they form an X. That means they're vertical. They're congruent. So If this guy's 30 degrees, that one's 30 degrees. And because it's isosceles, this guy's going to be 30 degrees. Okay, now we're on the home stretch. 30 plus 30 is 60. We subtract it from 180. 180 minus 60 is going to be 120 degrees. And that's the answer we are looking for, though we had to start way up on the other triangle. All right, here's a similar deal here. Number 10, we know this is isosceles because of the 2 tick marks. We know the other one is isosceles because of those 2 tick marks. We're trying to find the vertex angle here, but we got to start here. This is a base angle of 54. That's a base angle of 54. 54 and 54 is 108 from 180, so that's going to be 72 degrees. Well, this angle and that angle are vertical, so if that's 72, this guy's got to be 72, which means this other base angle has to be 72. So adding those up, that's 144, if I did it right. Let me check my notes. From 180, and let's see, yes indeed. So that's going to be 144 from 180 is going to be 36 degrees. And that's problems 9 and 10. All right, for problems 11 and 12. One of the things I like about geometry is that it makes some amount of common sense if you just look at the diagrams. For instance, many of you probably intuitively know if this side is 7, that guy is going to be 7 also. Now the clue here is, you see that tick mark and that tick mark, even though they are offset, they are a single little line, which means that angle and that angle are identical. They're congruent. And that means this is a bisector. It cut it in half because if you've got 2 identical angles with a line between them, that meant that that cut it right in half. Okay, so what does that tell us? Well, it tells us because this is isosceles with this one, and if that cut it right in half, then this is the halfway point here as well. So if that's 7, then this side is 7. And most of you probably just knew it would be 7 anyway without doing all that thinking. Okie dokie. Well, let's look up here. What are we trying to find? Measure of angle 2. Well, let's see. Where do we want to begin? Well, we've got to begin with the numbers. Well, I'm going to start right here. This is 110, which means this is 110 because they're vertical. This forms a linear pair, 180, so if that's 110, this guy's got to be 70. Because this is an isosceles triangle, if that's 70, this is 70. And 70 plus 70 is 140 from 180, so this angle has to be 40 degrees. Now, notice that that forms a right angle with angle 2. So if this part of the 90-degree angle is 40, this part has got to be 50. Okay, so we've solved for angle 2. We know it's 50 degrees. Now we're going to solve for x. We put it up here. The measure of angle 2 is 50 degrees. We set that equal to 6x plus 2. Subtract 2 from both sides, and we get 48. And divide by 6, so x would equal to 8. And that's example 11 and 12. All right, for the last 2 examples, 13 and 14, we're dealing now with what's called the exterior angle theorem. And what I'd like to do is just draw a little diagram here. And if you'll draw that with an extension. And we'll call this angle A, angle B, angle C, and angle D. Notice that angle D is on the outside of the triangle. That's why we call it exterior. It's on the outside. And the magic here is that this exterior angle D will always be equal to the sum of what we call the remote interior angles. In other words, this angle and these two added together will always equal each other. So let me say it one more time. The exterior angle will always equal the sum of these other two angles, and that's the theorem. So in this case, we're looking for angle, well, we'll call this angle QCB. This is the exterior angle. We know it equals to these two added together. So let's write it down here. Angle QCB equals 63 degrees plus 70 degrees. So that means angle QCB is equal to 133 degrees. Now, if we wanted to, since we know this is 133, we could quickly find that angle too by subtracting from 180. Now, over in 14, where it's obviously we've got more algebra to do, it's still the same thing. This exterior angle, I'm drawing like that, we know this will be equal to the sum of these two. So we can just set it up this way. We know that 13x minus 10, that exterior angle, will equal to 66 plus 5x plus 4. Now, I'm looking up here to remember that when we're all done solving for x, we need to plug it in because we need to find the measure of KEF. So, let's see, what do we got going here? Well, let's add the 66 and the 4, so that's going to give us 70 plus 5x. So I'm going to do two things at once. I'm going to subtract 5x from both sides, and I'm going to add 10. So 13x minus 5x is going to give me 8x over there. 70 plus 10, I may have said subtract, but we're going to add 10 to both sides, is 80. So divide by 8, x is equal to 10. Now, if I'm in a hurry, I might be tempted to just stop there, but remember, we're trying to find this whole angle here that I've put in that big marker. So we're going to plug the 10 in. So we're going to plug 10 in here. 10 times 13 is 130 minus that 10. So that's going to be 120 degrees would be our answer. And that's it for the notes.